Okay, perfect. Are we ready to start? Brendan, are you ready?
Yeah, I'm good.
Okay, perfect. So, thanks for joining us in this presentation. I hope you are here mostly for the wine than for the other technology, because that's the important bit. I'm Francesco Tisiot, and I'm joined by Brandan Tierney into this talk about a lot of things happening in the Oracle landscape around machine learning and data in general. So first of all, who we are. I'm Francesco Tisiot. I'm the analytics tech lead of a company in the UK called RittmanMead. And you can find me on Twitter or everywhere in LinkedIn, every kind of social media. And then we have Brendan.
Good morning, everyone. So my name is Brandan Tierney. I'm based out of Dublin in Ireland. So I don't work for RittmanMead. I'm an independent consultant based here in Ireland, kind of working on analytics, kind of databases development side of things, and with a kind of a long time exposure of nearly 30 years of working with machine learning. So Francesco, do you want to introduce us to the topic then?
Yeah, just one thing to mention. So you would try to guess why an Italian guy and an Irish guy are talking together about something. The reality is that we both love wine. Before going in deep, just a few words about my company, RittmanMead. It's an analytics and data company. We work on three main pillars. First one is data engineering. We take data from any source and we move to any target. Second one is analytics. We started with classic kind of enterprise BI reporting, and we do also self-service now with upgrades. And third is machine learning. So we have a bunch of data scientists within the company that can help you out. Okay, this is done. Let's go to the topic. The topic is wine. Me and Brendan, we both love wine, but we have kind of a different approach when going to choose a wine. This is what I do. I walk into a bar and ask, can I have a glass of wine? Usually on the other side, you have a waiter that says, well, sir, what kind of wine do you want? And then what I usually say is, let me see what you have. And then based on my preferences, I will pick what I like, what I mostly like. On the other side, we have my good friend Brendan that does the same. He walks into a bar and he says, can I have a glass of wine? Always the same response. What type of wine do we want? And his usual reply is some red wine. As you can understand, this is the perfect time for the waiter because he can basically empty all the half-empty bottles that he has in the counter, like 2 months. He put them into the same glass and gives to Brendan because he really doesn't understand anything about wine. It's not completely true. Brendan is a little bit smart. So if, for example, instead of just saying any kind of wine, the way I ask him, do you want some English wine? He's smart enough to say, well, English, I never really listened about any English wine. So I don't think I will take it. This is really basic knowledge about wine. I'm Italian, so we are producing a lot of good wine. In Slovenia, I know there are a lot of great wines. I don't think England is the best country, as we will also see later, for producing wine. However, what happens if the waiter says, do you want a Croatian Cabernet? He doesn't have the knowledge. Probably I will not have the knowledge to understand if that is good or bad. What if instead of guessing, we could have, for example, an app or a website where we can check immediately if the wine that they are trying to give us is good or bad. And then checking with this app, checking with this website, we could say, well, let me check. 95% chances that that wine will be good enough for me to drink. So yes, please give me this Croatian Cabernet. What we built here is a solution to help Brendan achieving this kind of confidence about selecting the wine. So where did we start? We start from a data set. The data set that we took is a public data set that you can find on Kaggle. Kaggle is a website that provides pre-curated data set on top of a various types of environment. In this case, it's wine data set. It contains a set of samplings of different wines made by different people. And at each sampling, there is, as we will see later, a huge set of columns. And the good thing about this wine dataset is that it is public and it can be used by anyone. So this is the dataset itself. It contains a lot of columns. The more important column is, of course, the ID, that is a unique identifier of the sampling, the points, which is what we will use to decide if a wine is good or bad, but also it contains the price, it contains the region where the wine is produced, the description that the person testing the wine used to describe the wine itself. So we wanted to create this predictive model. So we had to take the data and to start visualizing it to understand what the data is about. So what did we use? Oracle Analytics Cloud. You have been to plenty of sessions today about, especially the ones from Philippe, telling you what OAC is about. And I have also a session later telling you a little bit more. But let's just start plotting this. The rest of the visualization that you will see here, it's all done with Oracle Analytics Cloud in a few clicks. So first of all, I wanted to understand the wine score. The wine score officially is from 0 to 100. But as you can see here, most of the wines are really between 80 and 100. What we did is we created an artificial threshold that around, for example, 89, that says that any wine below, with a scoring below 89 is considered as bad. Every wine with a point system, an average price over 90 is considered good. This is just what we felt in order to divide more or less equally the data set. Then, as Philippe mentioned before, you can use the power of the database within Oracle Analytics. So one thing that you can do is doing, like in this case, tokenization. I want to understand which words are used by the people when writing the review of the wine in the description field. So I can create all the tokens, take all the words in the description field and expose them. Or, since we are, again, using a visualization tool, I can expose the amount of reviews per country. And as you can see here, it's a US-driven dataset, so most of the reviews are from US wines. And also I can show the price. Another column was the price itself. And as you can see, for example, Switzerland has the highest price, the highest average price, but also Italy, France, and a lot of other countries have a good price range. And the most important thing, I want to start on understanding how much I should spend for a wine in order to have good chances of being good. And then I can easily plot that. So I can see here that if I spend from 0 to 10 or from 10 to 20 or from 20 to 30, I have really less than 20% of chances to having a good wine. Again, remember that this is a US data set, so also the prices of the wine are US prices. This is the first step. I started attaching to the data, doing some transformation and some analytics. And then the second step is by Brandan.
So what Francesco has been able to show us is by kind of taking a data set and being able to explore it using some of the tools like OAC and various different charting methods, we can get to see some insights into the data, right? We can start seeing some patterns that might be occurring in the data. But when we do this is that, you know, sometimes those patterns that we discover can be quite shallow, as in like, you know, maybe only across a few attributes, maybe down by a few values. And, you know, us as humans, we get it difficult to be able to kind of delve much deeper than that. So what we want to be able to do is, or what we'd like to do in our prediction system is kind of going, can I actually look to see if there's any more deeper patterns in the data? So can I actually pull out, you know, important words that will help to identify whether something is a good wine or not, or maybe certain combinations of reviews or the words and the phrases they've used within those reviews for certain types of wines in certain regions, maybe based on certain grape types and so on, is, you know, it's very difficult for us to be able to pull that out, and even through like tools like OAC to be able to pull that out. So this is where we kind of need to move on to looking at, well, can I use something a little bit more sophisticated, some of these pattern discovery algorithms. And this is where kind of the label of, you know, machine learning, data mining kind of comes in, which is kind of the light bulb, being able to discover that. And, you know, if we look at the database, you know, usually the database is not associated with machine learning because, you know, everything you read about is, you know, over the last couple of years, it's Python, you know, before that was R, but pretty much or nearly everything you can do in those languages for machine learning, you can actually do in the database using SQL. You know, and as of kind of this time last year or nearly this time last year, these are now all free within the database for you to go and use. So if you kind of take your typical type of algorithms for, you know, regression, classification, clustering, time series, anomaly detection, feature extraction, lots of, you know, machine learning pattern discovery algorithms within the database. So they're there. So what we're going to do is, you know, as trying to solve this problem is we're going to use some of these elements from the text mining aspects of it, which has been in the database nearly as long as the machine learning algorithms. So take some of that text mining capability, combine it with some of the machine learning capability to be able to see is, can I actually do better predictions about the wine? So when I go up to the bar with my app and kind of go, you know, let's have a look at the menu of the selection of wines, or the barman tells me what they have, I can make a much better and a more informed prediction of what we were trying to do. Next slide. And in addition to all of those machine learning models that we have, is that the database comes with over 400 different statistical functions. Again, if you think about, you know, people who are going to be doing using R or Python or lots of other kind of products for doing, you know, statistical analysis, you know, like, you know, some very well-known ones out there, is that, you know, all those functions that those tools do or allow you to do are actually there within the SQL language. So there's a little bit of the RTFM. We need to read the fabulous manuals, you know, a little bit more. And if you kind of think about it, is that, you know, every time you want to do a statistical function or statistical test, is maybe we need to do a quick lookup of the documentation to be able to see what is there. Now, we keep on hearing about, you know, windowing functions and analytical, you know, SQL functions, but, you know, there is lots more of, you know, your bog standard kind of statistical functions within the database. But how do we access all of these? And there's a variety of different ways of being able to access, you know, the machine learning statistical functions in the database. Now, if we kind of go with your kind of typical approach of maybe using SQL Developer or SQL Command Line, is, you know, once you can write SQL and PL SQL, whatever tool you have, you can access these. But in addition to that, you know, Oracle has kind of built kind of other tools and other interfaces for us to use, because, you know, maybe you are, you know, in your company, you are like the R language, like, you know, that's your language of choice. Is they've created interfaces to be able to run on top of the database, so that even though it looks like you're running R commands, you're actually running SQL statements in the database and using the database as like a compute engine to do all that kind of processing for you. And coming soon, we're going to have something similar for Python. And by doing this, is that, you know, we can also expose not just the data, but the machine learning and, you know, statistical analysis that we've done. We can expose it to lots of other tools, whether it's to like OAC for doing other analytics, but we can also kind of REST enable it to allow developers to be able to access that. And we'll come back to that in a few moments. And another thing that we're going to have a quick look at in a few moments is this kind of newer tool, which is to do with Oracle machine learning notebooks. So this is like your Zeppelin or your Jupyter notebooks of how you can actually interact with the database. So it's an alternative way of being able to do that. And we'll go through a demonstration of that in a few moments. But if we actually look at some of the base commands of what you need to do, because, you know, it is SQL, it is PL SQL of what we're trying to do. So within this is that, you know, I'm coming and showing you an example of, and it's a very simplified example of it. You know, there's lots of work that goes on before we get to this point, and a bit of work that needs to go on afterwards. But this kind of shows, well, here's one PL SQL statement that I can use to create a machine learning model. And in order to be able to do this, is that, well, there's a few kind of parameters to set. So the first one is to do with setting the model name. And this is just a text description that you can refer to at a later point. The second one is to do with, well, what kind of machine learning are you doing, right? And now one of the things we can set up is, separately, we can define, our settings table, which is actually the last parameter in that list, which tells us what all the hyperparameters are for the machine learning model. Or we can just take all the defaults, and usually the defaults work quite good for us. Then the next one we need to find is, well, what's our input data set? So what are we going to learn from? So we have this wine data set, and we'll have it defined that it has all the attributes we need, all the text descriptions we have. But the other thing that it also has is our bins. So the way Francesco talked about, hey, anything 90 plus is going to be a good wine, and anything less than 90 is going to be like kind of a bad wine. So we can actually say is, this is your kind of target on it. So if you're kind of used to working with Python, you have your X and Y kind of variables on it. So this is kind of telling us what those are. And then the final thing then, as I've mentioned already, is to do with the settings. But we will show you an example of that in a few moments. And when we move on from that, is like, well, how do I use this machine learning model on my data? And there's a couple of ways you can use it. Well, the primary method you're going to use is you're going to use some SQL functions. And you can either pass in data from a table, or what we can do is some dynamic scoring of data, or the dynamic labeling of data. So this is where we can, as maybe we're capturing data in our applications, we can go, hey, feed this into the database. Can you use the machine learning model to do a prediction based on these values? So in this example is like, hey, can you do a prediction of, here's using this machine learning model. I want you to tell me, is this going to be a good wine or not? And hey, I only have 3 values on it. I have the price, I have the variety, and I have the country. So can you tell me roughly what, whether you would recommend this or not? And this is where you can start doing, a bit of what if analysis. So you can go, oh, $25, it comes back and says, that's not a good wine. But what happens if I went for one at $26 or $27 or $28? How far do I have to go to suddenly get into being a really good wine? So this allows us to have that kind of dynamic aspect to doing this machine learning. And this makes it really useful. Again, if we can wrap this up into like, a REST service, and so that we can have that the URL kind of call and being able to pass those in as parameters, it makes it a lot easier for our developers to start using this functionality in the database. So if we move on to looking at the Oracle Machine Learning Notebooks, and this is kind of notebook is available on the GitHub repository, and we can share that link to it. And what we've done is we've taken that data set, we can load it in. As you can see, we have our different cells and we have our different results on this. So just like your Zeppelin and Jupyter notebooks, we can do lots of exploring on it. But there's some extra features within this that allows us to do it. So when we get into doing this, we're going to explore the data. We're going to create our different bins. So this is the code that we're going to add in the attribute, and then we're going to update that attribute based on the number of points it has. So this is where we're preparing the data. We're just going to check that, hey, we've created those bins correctly, and everything is good as far as we want it to be. The next thing we need to do is we actually need to change the data type of the text description that we have. So the actual review of it. Because we're using Oracle text, we need to change the varchar into being a clog. So that's kind of just a simple kind of thing on that. And then from there, what we're going to do is we're going to create what's known as our training and test data set. So the training data set is what we feed into the machine learning model to create it. And then we have a holdout data set where we can do some testing of it to see how good it actually was. And we can either use the sample function, or maybe like our hash to be able to do all of that. From there, well, we just kind of verify the data that we have, and we can start looking at, well, maybe the distribution of the values on it. One of the other features that we have within the Oracle Machine Learning Notebooks is that we have kind of built-in charting in it. So kind of, I just write a select statement and it will automatically convert it into different charts. So you just kind of need to be kind of a little bit careful on which ones you select and how meaningful it would be for what we're trying to do. So that's what we're doing. And here's another example of being able to here's the distribution of values across all the different countries. Maybe in reality, we need to do certain rebalancing of the data set, but let's not worry about that for now. And when we use these notebooks, we can share with other people and we can parameterize the queries for creating these different charts. So we can display data in slightly different way and being able to compare it rather than having to rewrite lots of code. So let's move on. Right, so the first thing that we want to be able to do now, or the next thing that we want to be able to do, is we need to look at the text that we're going to be processing, and this is where we're going to be using Oracle text to be able to format the data, to look at kind of that text description and being able to tokenize it and do a few other different things on it. So there's a few basic setup that we can do. So one of the most typical one is we need to do a stop list. Now, Oracle text comes with about a standardized set of words, which is like these common words, like some of the examples that you see here, for about 8-10 different languages. But then you can add to it, so you can have like domain-specific terms that maybe they're just common phrases that don't actually mean anything for it. And then we can take that and we can say is, well, what kind of searching are we going to do? What kind of stemming are we going to do? So it's kind of partial word searching, and then we just define that policy. And from there, we can actually use it within some of our machine learning. So the first step we can do is we can use the attribute importance algorithm to look at, can you tell me, what attributes or maybe what values within the text descriptions is actually meaningful for us. So here we actually define the model, and then we can pass in the settings for our text policy. And then once we've defined those settings, then we can actually create that attribute importance model on our data set. And when we run that, that's just running through some of that. So when we run that, we get to see is, what are the important attributes that contribute towards a good wine or a bad wine. We also see from the text description what words might be actually useful in this. And this is where sometimes you kind of going through this, you get to see some domain specific words that in a particular domain don't really mean anything. So we can go back and adjust the stop word list to be able to include those. From there, we can move on to going like, okay, we've gotten a bit of better understanding of our data. Let's move on and create the actual machine learning model. So in this particular case, we're just going to create one, which is going to be a random forest. But in a real world scenario, you'd actually go and use quite a few of the other algorithms, because there is the kind of the principle of there is no free lunch. You don't know which one is going to work best for your data at this point in time. So we need to try them all out and experiment on what it might be. So we define these settings using that text policy again, and then we can create our model on it. And from there, what we can do is we can apply to our holdout data set, which we can use then to evaluate to see as well, how many did I get right and how many did I get wrong? And this gives us some insights into how the model is actually kind of performing from there. And we can take those results and we can chart them, and we get to see we have a very high lift gain here, which kind of will give us a kind of a good indication of how good the model was at doing certain predictions. And then we can apply that model using the prediction function and the prediction probability function to be able to predict, say, new value. So here we get to see is we can see what the prediction probability is and the predicted value is. So we can actually compare that, and we also have the original values there, so we can do those comparisons on it. And from there, we can do lots of kind of different charting. So once we've kind of gone through that kind of phase of doing all of that, it's kind of looking at, how can we actually use some of that? So I'm going to hand back to Francesco, who's going to, look at how, you can take that and maybe kind of build a very simple Apex app to support that.
Okay, I'm skipping all the slides that were just in case we didn't have the video working correctly. And it's basically the same thing as the video. As Brandan said, we are also using the wine reviews, so the description, and we are tokenizing the text. Once we have this model, since it's in the database, we can use the SQL and any tool that can speak SQL in order to access it. And one example is Oracle Apex. And with Apex, we can create, for example, tables with all the different attributes of wines that we want to filter and look at. And of course, if you see the last column, it's the probability of the wine being good or bad, and you have also the prediction there. So it's really simple because you can just write SQL and extract the information. And we, of course, with Oracle Apex, we can also create charts. However, since our main knowledge is, since we want to create analytics, let's go back to Oracle Analytics Cloud. And again, I'm creating visualization just by importing data, which is in a form of a views or a SQL in the Oracle database. As Philippe said, this was an old version where I had to write the SQL in order to create the prediction. As Philippe mentioned earlier, we can, at this point, just register the machine learning model created by Brandan in the database. I can register that model within Oracle Analytics Cloud, and I can just start using it. So we can have the data scientist, Brandan, creating the perfect model, and me as an analyst just using the output of the model. And this is more or less the same thing that Brandan was showing you before, the attribute importance. I'm creating a chart on top of what Brandan created before, showing that, of course, the price is the main indicator if a wine is good or bad. Then also the province, the name of the taster. So you can also understand that the taster brings a bias in the information. Every person has his own favorite wines and also his way of ranking things higher and lower. But also the word rich or complex. So if someone writes a description of a wine using the word rich and complex, those two are really cool indicators about the wine being really good. Then I did something else. I did kind of the same graph as before. Before, what I did was I plotted, based on only the base knowledge that I had, how much I should spend in order to have a good wine. And we saw that if I was spending less than $50, I was having less than 50% of chances of having a good wine. Now with this predictive model, I'm actually using predictions made by the model created by Brandan. If I spend the same $50 using this prediction model, my chances of having a good wine are already over 60%. So I have already a huge increase in the chances of having a good wine, even if I'm spending the same amount. This is just because before I was analyzing only the wine price. In this case, the model itself is analyzing the price together with a lot of other attributes within the dataset. Since we are looking at the data, I wanted to do a step forward. So I'm really proud of my nationality, and I was expecting the Italian wines to be the best, of course. The French guys will do the same, the Slovenian guys will do the same. So what I did, I created a plot with country and the probability of picking a good wine from that country. And I guess you can all imagine which is the country which won. Well, not really. The country which won was England. So I was quite surprised. Why is English wine being the best? I said before at the beginning of my talk that Brandan was smart enough to refuse English wine. Maybe it's not smart enough because this clearly shows that English wine is good. So we have a powerful analytical tool. So I used that in order to do deep analysis. And this is the first. You can see this is, again, Oracle Analytics Cloud. You can put images, you can put GIFs. It's not animated as of now because it's just a screenshot, but you can put whatever, not only data, but also you can put images to create a story about your data. So I wanted to understand why England. And what you can see here are like 4 columns. Each column is representative of a country. We have the first column being Spain, second column being Italy, third column France, and the fourth England. The first thing that you see is the number of samples. We have 4,000 samples of Spanish wine, 10,000 samples of Italian and French wine, and only 34 brave people who tried to sample English wine. So this is already telling you a truth that there is not a lot of people that is willing to try English wine. The percentage of good and bad wines. With Spain, we are 70% of our training data set is considered good, the rest bad. Italy and France are towards 22 and 28, so less than 30% of good wines. With UK, in our training dataset, we had almost 70% of wines considered bad. Considered good. So as you can understand, since the machine learning model learns from the data, he's already starting understanding that English wine is good from the training dataset. Even more, if you plot the price, we start from $28 per bottle in Spain. We go around 40 for both Italy and France, and England is over 50. If you remember before, the attribute importance was already telling us that price was the first driver of our good dataset part. So if you start mixing English wine, very few reviews, with a high percentage of being good wine with a high price, you can start understanding why the model thinks that English wine is the best. But okay, I wasn't satisfied, of course. I didn't agree with the model, so I wanted to go deeper into the model, and I actually understood why we had this situation. Because you see 34 reviews, all the 34 reviews were done by a single person. So this is an important factor. You can build a perfect machine learning model, and I trust Brandan, he did a good job, but still you have to analyze deeply your data set, because you could have, like in this case, corner cases, which are screwing all your data set. At the very end, we understood this, so I can go back to Brandan and we can speak and we can improve the model. We can, for example, as we will also see in my next session, we can remove some parts of the data because are not, are basically just corner cases, are not really representative of the truth of my data set. And then what we can do also in Oracle Analytics is build a dashboard. This dashboard is available on a computer or on a mobile, and I can simply say, okay, I'm going to the shop today. I feel I want a wine from Vienna, and I click on Vienna. What this dashboard will do is will filter all the rest of the charts with the selection that I did in Vienna, and will tell me, look, that if you want to buy a wine from Vienna, you should buy this type of variety, and within this type of variety, I suggest you, and you see the table on the right, this type of this label of wine for this price, and you will have, for example, the 98 probability if you took the 13 label of wine of having a good wine. So you have all the information now to make a better decision based on data, not based on just ideas that you have in your mind. Next to Brandan.
Okay, so when we get to the stage of exploring data and finding some patterns in the data, being able to do some machine learning on it to find those different patterns, and then being able to explore those predictions to be able to find other patterns within the data, you get to see that within a data science machine learning project, actual machine learning is actually quite small. All of the work that goes on at the beginning to find that pattern discovery in the early stages, and then after the machine learning to do other kind of discovery of the data and other enhancements. So as you can see, it's quite a small thing. So when we start kind of looking at, well, we've developed all of this, it's kind of like, so what can we do with it next? And this is where we can start sharing it beyond our Apex or our OAC. We can move beyond that to working with our developers, where they're working in JavaScript or whatever other language that they're working with. And how they like to work is using different API calls, or using different REST services, being able to call different functions and being able to do different things with our data. So what we have here is just a little kind of short video that we're going to play now, which brings us through the process of, well, how can we actually do this? So within, say, the Oracle Cloud, we can go along and use, say, Apex as our interface for setting up the RESTful services on it. And what you can see is, I don't have to write a huge amount of code to be able to do this. In a lot of cases, just to set it up, it's just a click or 3 clicks of the mouse, and it will go and set up my schema to be able to REST enable it. And from there, what I can do is I can start exploring how to do this. Now, when it does go and set up those RESTful services, it also, like, so we can see this in Apex, some examples of how to do this. So even if we've never done it before, we can actually learn from the very simple examples that it has. So I'm just going to take a copy of that URL, go to a site where I can actually test it. And when I run that, we get to see the results come back, pretty much instantaneously. And when I look at the response body, we get to see that, oh, that's a little bit difficult to read, but it's coming back in JSON format. Again, that's what the developers are used to doing it. But maybe, from a database perspective, I want to make it a little bit cleaner so that it's more understandable to use. So I can convert that output to being just in CSV format. So this is easy for me to go and see, yeah, that's the data I want. That's kind of the structure I want. And maybe when I'm finished creating this, I can, flip it back to being JSON. So let's go and create some REST services for our wine data set. So we're going to create our module, and then we're going to start creating some templates for it. So it's going to be based on our wine. And we're going to just build it up kind of, using some kind of very simple queries. So for example is, hey, I need to define, well, it's going to be a query and the format so that I can easily see what it's going to be. It's going to be in CSV. And then what I'm going to do is I'm going to do hey, bring me back all the records within our wine data set. So can I actually build up a call for that? Take a copy of that URL, just go change that, run it, and we get all our data coming back. So that's nice and easy, and that's kind of building upon those kind of simple examples that they've already given you. But when we start looking at, building this out a little bit more, let's have a look at, well, can I put some, queries on, that might use some analytical functions that may do counts or maybe do parameters on it. So in this particular case, we're going to do a simple count. So as build up the interfaces, how many wines do we have from the different countries? As I wait for myself to finish typing that, we take a copy of the URL, we go back to our test site to be able to run that, and we'll be able to get our results coming back. So whether it's in CSV or JSON, we can easily switch between them. But kind of building upon that, we can start looking at, well, can I parameterize this? So can I build up a REST service with parameters in it? So, in this particular one, I'm going to do a query, bring it, set it to JSON. I'm just going to do pagination of 10. And in this case, I'm going to do is, bring me back all the wines from our data set where country is, based on a particular parameter value. So when I save that, I'm going to take the URL again, copy it into the website for test, but now I can actually change this. So I can change it to being, hey, Italy. Because of Francesco here, we have to look at the Italian wines. And here we can actually see this. Now, if I wanted to select it for a different country, I just have to change that value within the URL, and it's there. So we can build this out, and we can create a whole series of different kind of REST services for us. And here's one that we actually can use the machine learning model that we've created to be able to do predictions. So this is where we can do that what if analysis on it. And not just on going to the site to check it, but I can stick it into a browser, and then I can change the parameters on it. So the different parameters, I think I have 4 different parameters on it. So the first one I need to change is what country do I want to pull it in from? What province, what's the variety of wine, so it's going to be very imaginative, it's going to be Portuguese red, all right, so it's not very imaginative, but you get the idea of it. And then we can feed in the price to it, so the kind of $30, and this tells me that, hey, it's a low quality wine. And then we can let our developers use this. So here's an example of taking the exact same URL and being able to use Python to be able to do this. So we can parameterize this, and what I have is taking a couple of calls to be able to see this, one at $30 and the other one at $31. So is there much of a difference in this? And so this is where we get to do our what if analysis. We get to see is that, well, by spending $30, it's kind of going to be a low quality wine, but by spending that one extra dollar, I can get something that's going to be potentially much better for us. So this is where we can easily build these up and being able to share these with our different developers. And if you want to go and read more, is that, you know, there's an article there on the Oracle magazine blog to be able to go and see and get all the details of, you know, in a lot more detail of what I've just gone through of how to create all of those kind of REST APIs for us. Okay.
Okay, always the backup slides.
There's the backup slides, yeah.
Yep.
And then it's easy to hand over to our different developers who can create, whether it's our mobile apps or whatever type of interface we can have. And it makes it a lot more dynamic and a lot more useful to us. You know, so no matter what language they use, or whether they're using one language now and redevelop everything into another language in a few minutes or in a few months' time or next year, you know, those URLs still remain in place for us. So next slide. So if we kind of start to kind of coming up to, you know, a few minutes left for the presentation. So let's kind of summarize some of the kind of the key benefits of using the machine learning within the database. And some of these benefits is that, you know, the first one that we're going to start with, well, it's kind of good for security. And within that security, it allows us to kind of keep everything in one place. And by having that in one place is that, well, we don't have to extract data out, you know, creating lots of different silos and not knowing who is doing what with what data. Because if we keep it within the database, we're constantly protecting it and ensuring that only people who should be getting access to that data is actually getting access to that data. And building from that, then we have the kind of the whole data governance aspects of it is, well, we know who's doing what with what data, we know what's being generated on it, we know who's using it, and it helps to also define on the rules around that. From there, we can easily deploy anything that we develop within production. So without having to do any sort of complex technical architecture to be able to support whatever the business logic around it, or having to translate into other languages, we could just use the rest to be able to call those SQL. And from there is, once we've done all of that, is kind of building upon particularly the first 2 points of the security and the governance, is we can easily share these models, these machine learning models, not just for, you know, the data scientists. You know, we would have seen with in previous presentation to ours, and in this one is about being able to build it within like OAC or other applications to be able to see the effect of that machine learning model and being able to visualize it in lots of different ways and being able to share some of those insights across the wider organization.
The second part is analytics. Of course, we see the potential of doing machine learning in the database, but before doing machine learning, you have a first step, which is exploring the data, understanding what the data tells you, what are the patterns, what are, as we saw earlier, the corner cases that maybe we should exclude from our dataset, or where we should change slightly the shape of the dataset in order to make it better for, or more general for our prediction. Second thing, you can do a lot. We saw Brandan using the notebooks to do visualizations, but it's kind of somehow limited or a little bit hard to create those visualizations and very interactive visualization within the notebooks. We have Oracle Analytics that allows us to create beautiful visualization on top of any data set within minutes. And then machine learning is a good effort by itself, but it's nothing without being able to use it and to talk with business, to talk back to business, because there is where you make actually the difference. And with OAC, you can create stories, you can include images, you can include, as Philip was showing earlier, you can include backgrounds, maps, and you can create a whole story about your data. And then it's very easy to use. I create a project, I create a machine learning model, I can share it with other people. Brandan, who is our data scientist, works only on the database, but he can easily share the model with me as a business user, as an analytical guy, and I can simply trust what Brandan did and go from there. So by using the power of the database, and the analytical tool together, you actually achieve results on both sides, the data scientist side, and also from an analytical point of view that were not, that I believe anyone else in the data ecosystem is able to provide to you. The last bit, which was already partially mentioned by Brandan, is what about money? We saw that we are using a lot of different technologies. Well, if you think about Oracle machine learning, which is the key bit, being able to create machine learning models in the database, as Brandan said, this since last December is free, not only in the cloud, but also in most, I would say, which covers, I believe, 90% of the cases, on-premises edition of the database. So if you have an Oracle database installed in your servers, you should potentially have already the machine learning option available to you for free. So if you think about having machine learning in a database, if you have on-premise, then it's fine. If you don't have an Oracle database on-premise, well, there is always the always free tier from Oracle that allows you to have 2 autonomous data warehouse databases in the cloud for free, always. OAC, as of now, is out of the always free tier. You have always the 30 days and $300 option to start using OAC. But this is the right time where you can show that if your data is in the database, you can use the power of the database, the security of the database in order to create machine learning model, and use the analytical tool which was built in order to work really well with the database in order to expose your results to your end users. So I hope you enjoyed this presentation. It was a real case test of putting technologies together. And I believe it worked really well because we got from a problem of trying to predict wine to multiple solution, which is a dashboard on OAC, or a wine app, which is fed by a database with REST APIs. So you have now no limits in order to use machine learning in the database and in the analytical stack of Oracle. Thank you very much.
Thank you.